Well, hello. We're going to continue working on operations with radical expressions. So our main thing today is to simplify products and quotients of radical expressions. So what we're trying to do is we're simplifying radical expressions. One tool that we're going to use today is using the concept of conjugates. So conjugates are the sum and difference of the same two terms. For example, 7 plus 3 and or square root of 7 plus the square root of 3 and square root of 7 minus the square root of 3 are both conjugates. But here's the cool part. The product of conjugates ends up being a difference of squares, which we've been working with as we've been factoring quadratic relationships. So the difference of squares, so we can see it right here. The square root of 7 plus the square root of 3 times, or the product, is the square root of 7 minus the square root of 3. We end up with the square root of 7 squared, which is 7, minus the square root of 3 squared, which is 3. So I'm trying to get to the difference of squares so I can just subtract out and I end up with 4 as my answer. So something to keep in mind on. As we work through these problems, you're going to see what you have, and then you're going to utilize kind of that opposite or that conjugate of that, and then end up finding the difference. And let's try that out. Like for instance, in this problem right here. Again, my whole main thing is just simplifying. So normally what I do is I look at my denominator, see some radicals there, and I want to multiply those radicals out, find the product of them. But this, I'm going to utilize what I just figured out. If I use the difference of squares, that'll help me. So I'm using square root of 7 minus the square root of 2. So I'm going to use square root of 7 plus the square root of 2. And then I'm going to also do that to my numerator. And when I do that out, I end up with 10 times the square root of 7 plus the square root of 2 over. Now remember what this ends up playing out over here. This whole thing ends up being the square root of 7 squared minus the square root of 2 squared. And the square root of a squared number is itself, so I end up with 7 minus, and square root of 2 squared ends up with 2. So I can keep chugging along on this. Now I end up with, in my numerator, I can distribute that out. You know, I'm going to rewrite that 10 times the square root of 7. And the reason I'm rewriting this is because I see something that will simplify out. 7 minus 2 is 5. There it is. 10 and the 5 simplify down. So sometimes you don't always want to distribute first in case you can factor something out. If we did that beforehand, we could still factor out and end up in this situation. Like if you distributed early, you are still going to end up with 2 times the square root of 7 plus 2 times the square root of 2. My denominator is 1. This is my simplified form. I could add these two together if they were both square root of 7 or if they were both square root of 2 and combine those like radicands, but I can't. Thus, simplified. Ooh, goody, you get to try it. All right, why don't you give it a rip? See what happens. Press pause. All right, when I simplify this out, I notice here that it's square root of 10 plus the square root of 5, so I'm going to use the subtraction, use the conjugate of it, so I can get myself some kind of numbers here. So when I simplify that out, I find out that the square root of a square is itself, square root of a square is itself, and I end up with 10 minus 5, and thus my radicals leave my denominator, and I continue to simplify, and this is what I end up with. I cannot simplify that anymore. All right, well, I am going to go and drink some suntan lotion, see if it'll help stop my sunburn.